Hello, this is Professor Dan Kernler of Elgin Community College. This video is part of my statistics series. This video is actually one of two that we're going to talk about how to make different graphs in StatCrunch. So let's get to it. The first graph we're going to talk about is a familiar one. It's a pie chart. So something like this graph here, which is from the Pew Research Center, the percent of people who are being harassed or bullied online. A bar graph is the next one. This is also one that people are very familiar with. You may see one like this. This is from that same study where people are bullied or harassed online. The third graph we're going to talk about is called a time series plot. This is how something varies over time. So within that same Pew Research study, there was about how these different types of harassments have varied over time. And you can see the x-axis there, the horizontal axis is years, so it's over time. The next type of graph is a histogram, which we're actually not going to talk about how to do that in this particular video. That'll be in the next video. But I do have a couple of examples. I've got here this age of first-time mothers, so the age at the birth of their first child. Here it is in 1980. You can see a clear peak there, 18, 19, 20 for the age for the birth of their first child. But interestingly, here it is again in 2016. A very different distribution, still a peak about 18, 19, or 20, but then a dip and another peak in the late 20s. So these are examples of histograms. The last type of plot is a stem and leaf plot. This is the most confusing and actually least common, but it's one we do want to mention. I've got a couple of examples here. What you have is some numbers along the left and then some other numbers along the right, and we'll talk a little bit later in detail about what those mean. So let's talk about a pie chart. And here, let's start with an example of our lesbian, gay, bisexual data. And let's do an example of how to make a pie chart of the birth sex. So this is pretty straightforward. You go to graph, choose pie chart, and then with data, select the variable that you want to do. I like to show just the percent of total, so I select that. Scroll down here, type in a nice title. We always want to have a nice title, and then hit compute. And you can resize it if you want, but that's the basics of making a pie chart. The next graph is a bar graph. You can do this the same way. In StatCrunch, it's called a bar plot. So you can do graph, bar plot, select the data. Let's do a relative frequency one. So this would be the proportion out of the whole. And again, you can go down, type in your title, and then if you want to modify the x-axis and the y-axis, and hit compute. And then there is your bar graph or bar plot. Now, sometimes it's important to consider which type of graph would be most appropriate. So within that same database is a variable about how much of the family the individual is out to. Is it all, most, some, none, or it doesn't apply? Maybe they're not out to their family at all. So we have this variable. We can make a pie chart of it, looks something like this. And we could make a bar plot of it, looks something like this. So the thing to think about here is this is really an ordinal variable. All, most, some, none, and then the fifth category there. But there's clearly an order, and so putting it in a circle, it's kind of weird because the all is next to the does not apply, and so a bar plot is really going to be more appropriate if you have an ordinal variable. Another important thing you can do with bar graphs is actually show a relationship between two variables where you have the variable you're interested in, maybe it's out to family, but then you can split that up by another variable. In this case, we're going to look at birth sex. This one is a little tricky in StatCrunch because we want to graph out to family and we want to group it by birth sex, but it doesn't work that way that you think it would in StatCrunch. So we're going to start the same way. We're going to do graph, we'll do a bar plot, and you'd think you'd choose here, we'll scroll down and choose out to family as the variable we're going to graph. Let's see, and then we can group by the birth sex. And we'll do relative frequency, but within the category. So that way, when they're grouped together, it'll be the proportion within that group. And then as usual, we'll go down, add a title, x-axis, y-axis labels. And then when we hit compute, we can see that this isn't quite what we thought it would be. Turns out it actually graphed birth sex and grouped it by their how much they were out to the family. So I'm not sure why it does that. So StatCrunch, I always have to just do it, see what it looks like, and then actually it ends up being the opposite of what I think it's going to be. So all we do, we go back in, we do options edit, go back in and switch what is being graphed and what it is being grouped by. And then when we hit compute again, we can see it looks like the way we want it to. And what this graph does for us is it lets us look to see if there's a difference between how much of the family the individual is out to, whether they are male or female. And in this case, we can see that the men are more likely to be out to all of their family. The reason why, who knows? There's no experiment here. This is just collecting data. So it doesn't mean that gay men are more welcome necessarily. It doesn't mean that men are more outspoken. We don't know, but it's just interesting to note that men tend to be more likely to be out to all of their family. Let's look at another, maybe more difficult to think about variable, and that's this: have you ever thought about killing yourself? So have you ever had thoughts of suicide? So this is a bar plot of that variable, and the options are no, yes, just once, or yes, more than once. So this is just overall. And we can see that this is actually a very common thought for LGB adults. More than half have thought about killing themselves more than once. What if we look at another side-by-side graph and we group by how much of the family they are out to? Maybe there's a relationship. People who are maybe more open and out to their family are less likely to have these thoughts. It's something to maybe investigate. So we can do a side-by-side bar graph, and here we have it here. And you can actually see here, if you look, the all versus most versus some. The ones who are out to all of their family are more likely to never have thoughts of suicide and less likely to have thoughts of suicide more than once. Again, there's no causation here. This is not an experiment. So we don't know that people who are more out to their family are necessarily going to have these thoughts less often. It certainly seems reasonable that people who feel welcome in their family, who have a relationship where they're able to share this important characteristic of themselves, would be less likely to have suicidal thoughts. But again, it's not an experiment. We can't claim causation, but there is certainly a relationship there between these two variables. All right, the next type of plot is a time series plot. This one is also a little funky in StatCrunch. So let's get in and take a look at that. So in StatCrunch, this is called an index or time series plot. So we have some data here from the S&P 500. That's a stock index from 2009 to 2017. We choose that. To get the x-axis labels, we have to go down and choose that as one of the options for the x-axis label and choose that specific date column. So that's a little tricky there. But then we go down and like usual, do the title, x-axis, y-axis, hit compute. And it's a pretty good graph. There is a problem though, that the y-axis on this, when you do the graph this way, is cropped. StatCrunch is automatically going to try to fit the data. And sometimes this can be very misleading, where it can show big jumps simply because you zoomed in. So we always want to start at 0. That's good practice. It's easy to modify. We just go down on the bottom left, hit those 3 bars. We can go to the y-axis and change the minimum and maximum to nice round numbers, minimum to 0, maximum to like the next nearest number that's nice and round above that previous maximum, and hit compute again. And then we get a nice graph that starts at 0 and ends at 2,500. Just to give you another example, a frequent one these days in the news is the time series plot of COVID-19 cases over time. So you've seen these in the news. If you've looked online at all, you've seen these types of graphs. This is called a time series plot. So this gives you a good idea of what is happening over time. So it's a very common graph and very useful to look at trends. Histograms we mentioned, we're not going to talk about those today. Those will be in the next video. The last graph we're going to talk about is a stem and leaf plot. This is less common, but it's worth talking about. It does pop up once in a while. So I have some fictitious exam score data in front of you here. So I've got scores from 52 up to 95. What we're going to do is we're going to pick out all the first digits and just put a column of those first digits. Those are going to be our stems. Then we're going to grab the second digits, so like 2 and 8, and write those in order next to the 5. And then the 0, 2, 3, 7, and 9 for the 60, write those next to the 6. Same thing for the 7, the 8, and the 9. And those are going to be our leaves then, and that is a stem and leaf plot. So that's it for this video. If you enjoyed this and want to see more, you can subscribe, hit the bell to get notified. I've got a whole series of these coming out. I also want to take a moment to thank the Elgin Community College Board of Trustees, who supported me for this project as part of my sabbatical during the spring 2021 semester. All right, thank you so much for watching. We'll see you in the next one.